find the projectile motion formula. The projectile motion is what? Is how to racing or how to launch a certain object. For example, when you launch this object like that, it means that this is the line of x-axis, this is the line of x-axis, the y-axis, x-axis. So when you launch the object, for example, from this, it moves above and reaching at the ground. So it means that the projection motion is the launching a certain object or launching is the through the object or launching object or projecting of or racing object. So then in the projectile motion there is some word or specific term. There is a term which called range. The range is the horizontal. This is the horizontal displacement. So there is also y or the total trajectory, which is called y, which is called total. Of object. So also there is another term which is called t for the total trajectory of object. So for that there is also which is called h max. This is called the maximum height reached by object. So there is another term which is called the t, time used. So for t, there is two categories. It means that time of flight and the time maximum at maximum height. So those are the terms necessary in this. So there is also another called angle of projection. So we are going to discuss for that. So how to find the range? When the object move above for that, so there is it's moved in two dimensions. It means that we have x and y. There is also the velocity initial for that. For the velocity initial for that, we have a velocity initial for x and velocity initial for y. So the velocity initial for x, there is equal, if the angle is equal to that, the velocity initial for x is equal this, we consider this, and v, with this according to that, it is equal VO, the general V cosine of angle theta. So for Vy is equal this, but there is also other variation. It means that it moves above, it is launching, there is gravitational acceleration. So it means that it is VO sine of theta minus gt, because there is gravitational acceleration for that. So those are the velocity initial for x and velocity initial for y. So this is the velocity initial for y is equal to that. So but for vx is what? Vx for that, it is equal, Vox is equal Vo cosine of theta. So also Vy is equal Voy plus gt with minus. So which is equal Vo sine of theta minus gt. So those are the formula for that. So how to what the h max for that is equal. So to obtain the maximum h for that, when the body reached or returned back to the ground, the h max for that, the velocity is equal to 0. So if the velocity y is equal to 0, then the maximum h, the object is returned back to the original, or it is returned back to the ground. So according to that, so when you consider this formula, so you see that VO y minus gt is equal to 0. So VO sine of theta minus gt is equal to 0. Gt is equal VO sine of theta. Then t at h max is equal VO sine of theta divided by g. So this is the time of flight at the maximum height. So this is called the time at maximum height, or the h max. So to find the formula of h max, we replace y, which is equal 1 over 2 minus 0 t square plus VOT VOEYT then plus h initial. So for the h initial there is a, because the into the initial, so then y is equal to minus 1 over 2 g t square is t over the h max, which is called VO sine of theta over g power 2, then also plus VOY. Remember that the VOY is equal to that, so VO sine of theta, then times t, which is also VO sine of theta over g. So when you multiply this and that, you get for that is equal h max is equal to minus g VO square sine of theta square over g square. So then plus VO square sine of theta square over g. So we simplify this and that. So then for that we find the common denominator. So then h max is equal to, when you find the common denominator is equal to 2 multiplied to that is equal to also VO square sine of square of theta. So this is the same to that. When you take a 2 minus 1, so we get VO square sine of theta square over 2g. So this is the h max, the formula of h max. It means that to reach for that, the h for that, to obtain this maximum h, we use VO sine square of theta divided by 2g. So this is called h max of that. So after h max for that, so also there is a certain range. Before to understand the range, so let's discuss about how to find the time of flight. So the time of flight is what? So the time of flight, it is the total time for reaching there. Time of flight is the total time for reaching there. It means that it's equal to time of h max. So it means that time of flight is equal to times t, which is equal VO sine of theta divided by g, which is equal to VO sine of theta divided by g. So the range, remember that the range is the total distance traveled by this object. So the range is what? The range, because it is the horizontal distance, the horizontal distance is equal VO is equal Vx, then t plus x0. So x0 is the result. So there is also the result, the acceleration for horizontal. We use this formula, which is equal VO cosine of theta times T, but T is not TH, it is the T of flight. So this is equal VO cosine of theta times 2VO sine of theta divided by G. So range is equal to VO cosine of theta sine of theta divided by G. So remember that when you see 2 cosine of theta sine of theta, by using trigonometric ratio, this is equal sine of 2 theta. So because the sine of 2 theta is equal to cosine of theta sine of theta, so then range is equal to VO is equal to VO sine of 2 theta over G. This not 2 is equal to RTG over G. So this is the range for that. So for that is the projectile from the initial, which is equal to 0, 0. So we use that. It means that the range for that is equal to VO sine of 2 theta over G. So the time of flight, remember that the time of flight is also that. So those are the principal parameters for this projectile. If you have any problem, ask on a comment. But don't forget to subscribe. We continue after how to find the range and how to find the range of a projectile when there is the initial head. How to find the projectile or how to find the range when the rocket is launched above the ground. So we are together. Good.